Hello and welcome to another edition of Eric's Philosophy Talk videos. I'm host Eric, the host of Talking with Famous People. And tonight I'm going to be talking to you about the thing called conditionality. Yes, conditionality. If you aren't familiar with it, it's the sentence in English, if blah 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 blah, then blah 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 blah. Okay? And for those of you who are more familiar with it, specifically what I'm going to be talking about tonight regarding conditionality is the odd phenomenon of conditional or symbolic logic or propositional logic. It's called a number of different things. It's called semantic calculus or something like that too. There's a bunch of different weird names for it. Anyway, it's very useful in computer programming. It's used quite a bit. And one of the odd phenomena that one encounters in symbolic logic is that whenever you have a negated conditional, you have a circumstance in which the antecedent is proved and the consequent is negated, is falsified simply by the existence of a negated conditional. Okay? If that doesn't make sense, I'm going to explain it right now, and I've even got some visual aids. I hope to go through this quickly and to cover the ground clearly and for people to be able to find this useful and learn things. Okay, I'm not going to waste your time. So, here's the first thing I got for you to look at. And I'll be holding that right there. Alright, so while you're looking at that, I'm looking at it on my phone. Basically, a conditional is an if-then statement, as you see here. The symbol for it is this backwards horseshoe. And an example is, if it rains, then I will bring an umbrella. It rains would be the P part, and I will bring an umbrella would be the Q part. And the P part is called the antecedent, the first part, and the Q part is called the consequent. So a conditional, every conditional has two such states, right? It's got two parts. It's got the antecedent and the consequent. Okay. Is it possible that all statements are conditionals? Well, probably not in any meaningful sense, but what is the case is that when you are talking about making a statement like, I'm going to vote for Bush, or I'm going to vote for Obama, or I'm going to vote for Rand Paul this time, or I'm going to vote for Bernie Sanders, obviously there's a conditional built in, right? Assuming the status quo, I'm going to vote for Bernie Sanders. Now, if Bernie Sanders dies between now and the election, you will probably reevaluate that decision. If Rand Paul makes a statement saying, as soon as I get elected president, I want to kill all the Jews, well, you're probably going to reevaluate your perspective on Rand Paul at that point. So you're basically, it is a conditional, it's just not an explicitly stated conditional. There are other statements, however, that you might argue more successfully are not conditional. However, almost all statements can certainly be reasonably begun with the sentence, if the status quo remains, assuming that the statement is about something in the future. Now, if the statement is about something that's already occurred, such as Judy went to the store, then there's not really any need for an implied conditional, although there is one, namely that assuming our senses are not deceiving us, assuming facts are as they appear to be. Something like that. Okay? So let's go on to the next part of the conditionality lecture here. And when we do, what we see is my next visual aid. When going through this particular proof, which is what I'm providing you, to show you that any negated conditional, like, it is not the case that if it rains, I will bring an umbrella, necessarily proves both that it rains and that you do not bring an umbrella. Which seems odd, right? If I tell you, if it rains tomorrow, I'm not going to bring an umbrella. I'm sorry, if it rains tomorrow, I will bring an umbrella. Okay? If you say that. In no world, well, then fine. Okay. But what do you say? Let me correct myself here. If it is not the case that if it rains tomorrow, I will bring an umbrella. It is not the case that if it rains tomorrow, I will bring an umbrella. What you probably means is that if it rains tomorrow, you're not going to bring an umbrella. You're going to enjoy getting wet in the rain or something. Okay? But the way the logic works out is simply stating the sentence, it is not the case that if it rains tomorrow, I will bring an umbrella, proves that it rains tomorrow, and falsifies that you bring an umbrella. Okay? So I'm going to demonstrate how using these visual aids here, using these particular rules of symbolic logic, some of which are rules of replacement, some of which are rules of inference. Okay? So if you don't know what the difference is, rules of replacement can be used in line. So in other words, if I have something in parentheses within a line of logic and I want to apply a rule of replacement to something outside that parentheses, that's fine. If I want to apply a rule of inference, I have to apply it to the whole line only. Okay. So here are some of the rules we're going to be using. Transposition is the rule of replacement, and so is material implication and double negation as well. These are all rules of replacement. You can use them anytime. You don't have to use it on a whole line. You can use it on a part of a line. All right. Another one that we're going to be using, referring to here. Oops, sorry, microphone. Made a loud noise, I bet. Another one is this one here. De Morgan's. De Morgan's tells you when you have the negation of a conjunction, that is an and, it becomes the negation of the antecedent or the negation of the consequent. And if you have the negation of a disjunction, P or Q, it is not the case that P or Q, that becomes the negation of the antecedent and the negation of the consequent. Okay? So if I say, it is not the case that Bob and Steve are going to the store, then either Bob is not going to the store or Steve is not going to the store. And if I say, it is not the case that Bob or Steve are going to the store, then that becomes, it is not the case that Bob's going to the store and it is not the case that Steve's going to the store. Okay? De Morgan's. Lastly, we've got this. Double negation. Oh, I already did that one. Okay. So let's now consider two examples of the actual material implications of material implication. The material implications of material implication plus De Morgan's when you're dealing with a negated conditional. Here are my two examples. They're both symbolized by the same thing. Not P, then Q. The first example reads, it is not the case that if porpoises speak Latin, Frenchmen will grow horns. It is not the case that if porpoises speak Latin, Frenchmen will grow horns. Okay? Number two, it is not the case that if Aunt May comes along, then we will get pie. It's not true. If Aunt May comes along, we're going to go get pie, right? No, Johnny, it is not the case that if Aunt May comes along, then we will get pie. The proof looks like this. It's pretty straightforward, right? It's only a few things. It's just a few little things. Okay? So first you see, it is not the case that if Aunt May comes along, then we get pie. Number two, you run material implication inside the parentheses, which you can do because it's a rule of replacement. And you get, it is not the case that not P or Q. Now that you've done that, you've got a negated or, a negated disjunction. So in step 3, you use De Morgan's. And that means you have not P and not Q when you run De Morgan's, that rule of replacement on line 2. And then in the final step, you get rid of the double negation on the P, and you end up with P and not Q. Perfectly valid proof. Simple proof, couple steps, only involves one thing, right? It doesn't, you have no other piece of information but the negated conditional, and you're just transforming it by the rules of replacement. But let's go back to our two examples. So what have we concluded? We've concluded these things. is porpoises do speak Latin. No horns for the Frenchmen. We don't get any horns. Aunt Mary does come along, and we do not get pie. Now, when we are talking in normal English about these sort of things, if we say, no, it's not the case that if porpoises speak Latin, then Frenchmen will grow horns. That's ridiculous. We don't think of ourselves as making a sentence that proves that porpoises speak Latin. But we do. So, be very careful out in the world when using negated conditionals. You don't want to prove something like porpoises speak Latin. Because think of the havoc and the mayhem that would cause. If all day long, all you heard was the sound of porpoises speaking Latin, you'd go insane. And that's one to grow on. Thanks, Conditionality, for defining the universe for us. I've been host Eric, host of Talking with Famous People and Eric's Philosophy Talk videos. Thanks for tuning in today for this lesson on conditionality.